IEEE GRIT PES SBC presents a workshop on design and development of a single-phase transformer. Components required: barbells, laminations, connecting wires, tools, stands, insulation paper, copper winding, soldering kit.
Introduction session and calculations on development of transformer.
Calculations for designing a single-phase transformer. Turns calculation. From EMF equation of transformer, E is equal to 4.44 into B into A into T into F, where E is the induced voltage in volts, B is the flux density in Tesla, A is the area of the bobbin in meter square, T is the total number of turns, and F is the frequency in hertz. Turns required to induce 1 volt of EMF. Rearranging the formula, T is equal to E divided by 4.44 into B into A into F. T is equal to 1 divided by 4.44 into 1.2 into 0.0014 into 50, where T equals 2.6, similar to 3. Calculating the number of turns required to induce primary voltage of 230 volts by multiplying number of turns required to induce 1 volt by primary voltage. 3 into 230 equals 690 turns. Then calculating the number of turns required to induce secondary voltage of 15 volts by multiplying number of turns required to induce 1 volt by secondary voltage. 3 into 15 equals 45 turns. Primary current calculation. From the transformer principle, I1 into V1 is equal to I2 into V2, where I1 is the primary current in amps, V1 is the primary voltage in volts, I2 is the secondary current in amps, V2 is the secondary voltage in volts. Rearranging the formula as I1 is equal to I2 into V2 divided by V1. I1 is equal to 2 into 15 by 230. The primary current I1 is 0.130 amps.
Calculation of size of the conductor. J is equal to I divided by A, where J is the current density in amps divided by mm square. I is the current in amps. A is the area of the conductor in mm square. Rearranging the formula as A is equal to I divided by J. For primary winding, A1 is equal to I1 divided by J1. A1 is equal to 0.130 divided by 2.3 is equal to 0.056 mm square. For secondary winding, A2 is equal to I2 divided by J2. A2 is equal to 2 divided by 2.3 is equal to 0.869 mm square.
Hence, from the standard wire gauge table, 32 standard wire gauge required for primary side conductor, 18 standard wire gauge required for secondary side conductor. Note that the next highest gauge number of the present value must be considered to ensure that the winding can safely handle higher currents.
Winding insulation tape around the bobbin. Removing insulation from the primary winding. Soldering connecting wire to the primary winding. Arranging the transformer winding machine.
Winding the primary turns. Checking the count of turns accordingly.
Insulation removal of primary winding second terminal.
Soldering the primary winding second terminal with connecting wire. Winding insulation tape around the primary turns. Removal of insulation from secondary winding. Soldering the secondary winding terminal with connecting wire.
Winding the secondary turns.
Insulation removal of secondary winding second terminal.
Soldering the secondary winding terminal with connecting wire.
Winding the insulation tape around secondary turns.
Adding lamination stackings to the bobbin.
Tightening the stackings with stands, nuts and screws through tools. No-load test on designed transformer from 230 volts side. Load test on designed transformer from 15 volts side. Final output with successful design.